So let us do one more problem based on trigonometric identities, which is very simple one, just based on what? Algebraic identity a cube plus b cube. If you know the formula, if you know the expansion of a cube plus b cube, you can solve it. It's a very simplest one. Let us see how to do it. See here, we have given sin power 6a plus cos power 6a. We take LHS sin power 6a plus cos power 6a. Let me rewrite the each term as, okay, here sin power 6a can be rewritten as sin square a whole cube. Okay, means this is square whole cube. If you multiply this 3 with 2, we get again 6 to the back. Okay, so that means sin power 6a can be taken back. So like this we adjusted. Okay, now this cos power 6a can be written as what? Cos square a whole cube, right? Okay, now if you observe here, this is in the form of what? A cube plus b cube. Let me tell you what is the expansion of a cube plus b cube according to algebra part. A cube plus b cube would be equal to what? A plus b into what? A square minus ab plus b square, which is a standard algebraic formula from 8th standard of CBSE or ICSE. Right? You might have learned this in 8th standard and 9th standard. Okay, this is a standard formula. You can apply it over here. Okay, so just see. If you consider sin square a as a, cos square a as b, a cube plus b cube, then how can we can expand this? A plus b. A plus b means what? Sin square a plus cos square a. Write it down. Sin square a plus cos square a into. Now this is now what? A square means what? Sin square a to that whole square. Sin square a is a to that whole square. Okay, minus ab. What is minus ab here? Minus sin square a cos square a. Cos square a plus b square. What is plus b square? B is your cos square a for that whole square. Write it down. Let me rub this as the space is not sufficient. Okay. Okay. Now, this was further expanded into this form. Looking a very big expression but very easy. Just see, you can observe here that this is standard trigonometric identity, means identity number 1, that is sin square theta plus cos square theta, value of which would be 1. So we can write this as 1 into. Now this sin square a whole square would be written as what? Sin to the power of 4a. Okay, sin to the power of 4a. Okay, plus minus sin square a cos square a. Okay, plus cos square a whole square can be written as what? Cos to the power of 4a. Now 1 we don't need to write actually. So now just 1 means we don't need to write 1. So here sin power 4a. Now group sin power 4a with cos power 4a plus cos power 4a minus this sin square a cos square a. Right? Now for my convenience, again I want to write it as something else. So I want to rewrite this as sin square a can be further written as sin power 4a can be written as sin square a to that whole square plus cos square a. For this also whole square we can write. This terms can be rewritten like this, minus sin square a cos square a. Now for my convenience again, see, I am telling you guys that when we add and subtract the same number or same expression to the given expression, it will remain same, because when you cancel them, it will remain same. Understood? We can add and subtract the same number. So for my convenience, I want to add and subtract, see here, sin square a whole square plus cos square a whole square. Now for our convenience, to get the problem solved, okay, I want to add and subtract 2 sin square a cos square a. Okay, this is cos. Okay, I have added. So we need to subtract again or not? Yes. Minus 2 sine square A cos square A. Here already minus sine square A cos square A is there. Write it as it is. Minus sine square A cos square A. Right. So don't be panic. Once again I am telling you what I did. See here, I wrote this sine square A whole square as it is. I wrote this cos square A whole square as it is. Now for adjustment into algebraic formula, okay, what I am doing here is I have added 2 sine square A cos square A. At the same time I have subtracted 2 sine square A cos square A from the expression. So if you cancel these two, again this expression remains same as before. So we added and subtracted, so there will be no change in the expression. That's the first thing you need to understand. Anyways, so if you observe here, carefully observe here, group all these terms till here, okay, up to here. What did you observe here? Sine square A whole square plus cos square A whole square plus 2 sine square A cos square A. If you assume that sine square A is A and cos square A is B, then this is in the form of what? A square plus B square plus 2AB. Is it an expansion of A plus B whole square or not? Absolutely. So we can write this as A plus B whole square, where A is what? Where A is sine square A and B is what? Cos square A to that whole square. Means this entire bigger expression is okay, converted to shortest one. Okay, minus, see this here, minus and minus symbols are there, and here sine square minus 2 sine square A minus 2 sine square A cos square A and minus sine square A cos square A, like terms are there. So therefore we can add here minus 2 sine square A cos square A minus sine square A cos square A can be added together to get minus 3 sine square A cos square A. Cos square A, right? Now we obtained this. Now if you observe carefully, here we obtained what? Trigonometric identity. First identity of trigonometry, that is sine square A plus cos square A, and value of it would be 1. So put it down. So 1 square minus 3 sine square A cos square A. Okay, 1 square means 1 itself only, no? So 1 square can be written as 1, and we obtained 1 minus 3 sine square A cos square A, which is our required RHS part. So therefore we obtained RHS. Okay, so we took LHS part and we obtained RHS part. So therefore LHS equal to RHS. So we got the answer. Hence it is solved. Understood? So like this we need to solve it. Understood? And one more thing I want to tell you here, if you have any doubts, don't forget to put them in the comment section. We'll definitely do answer if your doubts are valid, and if you ask us any other topic to do, definitely we'll do in our upcoming classes, right?